This video to show you how to do that type of connection with two base plates related to a different column. So first of all, I'm going to create this channel. I can use the call form. It looks like it's a call form. I mean, it's not going to select a call form steel material, but at least we have some shapes here that you can use. I'm not sure about the exact dimension. I'm going to just use this one here, probably 8 and 4, but you can always change this member shape, right? So you can also come here and select the appropriate material. I'm going to select A36. Okay, so now we have this column here. So I'm going to copy this other column and I'm going to just rotate it. Actually, I'm going to use a mirror option. Okay, so both of them are located in the 0, 0 position. So what we can do here is either if they have a space or they don't have a space, as you shown in that picture, but you can just use this offsets to move these members to one side and then to the other. So my recommendation is that the working point is always at the center of the two of them. So I'm going to move M2 2 inches and then B1, it's going to be -2. So probably we'll need more, -4, and then the other one 4, 2. So depending on the space that you have there, but my recommendation is that we keep the working point in the center, okay? So this is one approach to, let me go back here to the view, to have two different sections, but at the end of the day, one of them will be your bearing member, okay? Here you have two sections. Then when you're in the load effects, you can add axial forces to two different sections. There is another way, like if you want to do that, to use this option here. Actually, you can almost use this option, which you can create two channel members with a distance between them. So you can go ahead and select one of the predefined sections here, all right? And there'll be two sections, and then you can add space like 3 inches. So what will be the difference compared to the one that I am modeling right now? So in this case, this section will act all together. So you will just add one load, or yeah, one axial force to these two sections at a time, right? So I'll leave this decision to you, but in the meantime, I'm going to show you how to add the base plate to these two elements. So as you probably saw, if you add a base plate to one member, then you cannot add a second base plate operation to the other element. So the workaround is to create this base plate from scratch. I mean, one of them can have that base plate and then the other will be created from scratch, but I can create two of them from scratch. So what you will do, you create the plate, like in this case, I'm going to create this plate for, let's say M2 first, and I can say 3, and actually I can relate this member to member local axis, so that will be in the center of, let's change it to M2 first, and then you can see that the dimensions are from the center of gravity of M2, so we can say 3 and 3, a little bit more here. Now this dimension is from the center, so we can say 6 and 6, right? So that will be one plate, so I can just copy this plate to B1, so I can relate it to B1, and this is just the reference for the base plate, right? Now, in this case, we're creating this base plate from, let's say, from scratch. So we're creating all the operations from scratch. So now we need to cut those members by the plate to add the weld, right? So we come here and say, okay, B1 is going to be, B1 is this one here, is going to be cut by SP2. You can hover the mouse over them and see the name of the plate in the lower left side of the screen. So that will be cut by SP2, right? You can say, okay, this will have just welds in the rear side. All right. And this will be 1/4 and then 1/4. I'm going to now copy this and now cut M2 by SP1. M2 by SP1. All right, so now we have that weld. And finally, we need to add the anchors. So you can add independent anchor operations using this operation here, the grid operation. And the fastener type will be anchors. And this will be related to first, let's work with SP1 first. So this will be just one plate, SP1, okay? Let me show you the top view here. You can define post-install anchors, which I believe that's the case. That's your case, right? Post-install or cast in place. We have this different type of anchors. And when you select cast in place, you have more options here. But in this case, it's post-install, I guess. This is in the new version 25.1.2. Okay. You define the size. Maybe they're going to be a different size, so I'll let you select the correct one. You can define the embedded plate, embedded length of that anchor. I'm going to say 8 inches. I'm not sure, right? But you then can modify the position of these anchors, like maybe it's 5 inches, and then the vertical input is going to be 2 inches here. So it's just in the corner. And now we can say, okay, I need another one here. So that'll be -10. Right, so remember that we are adding the spacing. And finally, then we add 4 inches. Let me add -4 here. So that'll be the 4 anchors. And this is relating the anchors to a new concrete block, okay? And this concrete block is related to SP1. Okay, so we can copy this and then add it to the SP2 plate now, okay? But instead of creating a new block in this second grid operation, we say, let's use the same existing block, which is going to be the same, right? As the first anchor operation. So for this, in this case, we can increase the size of this anchor to keep this plate inside. So we can increase the offsets here, 24, something like that. But this is a slab, so you can just increase the offsets here, and also you can increase the depth. You decide what depth that will have. And now we have two operations, two base plates for 2 different members. Again, in this case, we have 2 independent members. So you can add forces to each of the members. The forces can be different if you need that. So that's the advantage of using 2 different elements. The option when you have one member defined by 2 channel members, the difference is that you will have just one member to apply the load. Okay, so, and they will act together. So we can calculate this, and you'll see that the analysis is running. And there you go. All right. Hope this helps. If you have further questions, let me know. I'm going to send you this file via email. Thank you. Bye.